Bismillahirrahmanirrahim. In this video we'll learn about Laplace transform, and primarily I will be talking about assessment number 13.10. Okay, so let's see what is the question here. 4s plus 3 divided by s plus 1 and s square plus 2s plus 5. Now this factor is fine, but this is in the form of a quadratic equation, so we have to make it into simple form. Let's see how we proceed. Now we're keeping the top numerator and this one same. We're just playing with s square 2s plus 5. So we write s square plus 2s into 1. We're just trying to get the formula a square plus 2ab plus b square. So s square plus 2s plus 1 square. So this completes the whole square. And now out of 5 we have taken 1. So remaining 4 is 2 square. And then from here we write this one as s plus 1 whole square plus 2 square. The other item remains same. And now since this is in the form of a plus, s plus 1 square plus b square, we need a minus here so that we can use the formula a square minus b square equals a plus b multiplied by a minus b. So to make this minus, we'll just manipulate a little bit. We write it minus j2 whole square. We know that j square is equal to minus 1. So minus minus will become plus. And now we can easily factorize this. So it becomes s plus 1 plus 2j, a plus b, and a minus b, s plus 1 minus j2. So these are the three factors now we have. So we can write in the form of a partial fraction now, and all the three terms separated, the three unknowns k0, k1 and k2 we are assuming. And now to find these values of k0, k1 and k2, there are several methods in the book. I prefer this residue method, so I'll follow that. In residue method we multiply fs by the denominator of the variable. So denominator is s plus 1, so we multiply fs by s plus 1, and then we put the condition s plus 1 equals 0. That means s equals minus 1. So this is the condition. So from this now, since we are multiplying by s1, so s1 and s1 gets cancelled. So this is what remains. And in this we'll plug in the value of s equals minus 1. So the numerator becomes 4 minus 1 plus 3, and similarly the denominator we plug in the values of minus 1, and now you can see this will become 8, minus 1 plus 3 will become 2, so 4 2s are 8. This minus this 1 and minus 1 will cancel for j2. Similarly these two will cancel for minus j2. So 8 divided by j2 and minus j2, and now we can multiply this. J square again is minus 1 multiplied by minus will become plus, so plus 4, and so the answer is 2. So k naught is equal to 2. Okay, now let's find the other ones. k1. So for k1 we'll again multiply by this term, so s plus 1 j2 fs, and the condition again we'll find from here that s, this thing is equal to 0. That means s is equal to minus 1 minus 2. So s is equal to minus 1 minus 2. That is the condition we'll apply. So the fs when multiplied by this term will reduce to this. This is present, this is present, this goes. So the remaining s plus 1 minus j2, and plugging in the value, you can see here s1 minus 1 minus j2 minus 1 minus j2 minus 1 minus j2, and then now simplifying, we get 4 2 minus j2 from here, and at the bottom we get minus j2 and minus j4, because this 1 cancels, so minus j2, similarly this 1 cancels, so minus j4, and multiplying we get minus minus plus, j square will make another minus, so minus 8, and from here we take 2 common, so it will become 8 1 minus j, and now we use our calculator to find the polar value of 1 minus j or 1 minus j1. So this is the value. Again, further simplifying will give you minus 1 minus j, and so we can write it to be minus 1 plus j, and now we'll use the calculator. So the value now we get is 1.414 angle 135. So this is K1. Exactly similar way we'll find K2. So we are just using the other value of K2, and same way we get the answer 1.414 angle minus 135. You can, if you look at it, these are the conjugate terms, so we can just directly, we could have written that the magnitude will remain same, the angle would be different. So that is another way. And now we plug in the values of K0, K1 and K2. So this is our function in form of Fs. Okay, so we were here, but this actually does not help us much because we have these two formulas. The first one fits in here, s plus a, so this is goes there, but this, there's no formula of this form. We can either use these formulas, so we have to convert these two terms into the form given in the denominator here. So let's proceed. We take the numerator term, this one common, 1.414 angle 135, so 1 remains here, and here also the magnitude is same but the angle is different, so actually we are dividing minus 135 by positive 135, so it will become minus when it goes to the top, so the angle becomes minus 270. Now one more issue here, that we need to, or we want to convert this in form of a j. So I minus 270, let's see how to convert it in terms of a j. Now if you recall the unit circle, this has a 1 here value, this is positive j, minus 1 and negative j. So minus 270 we could write directly that if you are going from here minus 90 minus 180 minus 270 is equal to j. Or there is another way that you just add 360. You can add 360 to any angle. So add 360, it will become positive 90. So positive 90 is j. So this one will replace by j. Okay, so we have placed this j, and now we'll take the LCM. Now taking the LCM, this goes at the left hand side plus j times this on the right hand side, and now we see how can we simplify from here. So after solving this will become minus 1, minus j2 and j will become minus j, and s plus js, so we write s plus js minus 1 minus j. And from here we'll take common, you can see, from here you can see, we can take s common, and here also we'll take 1 common. So s, if we take common, it will become 1 plus j, and from here we take minus 1 common, so it will also become 1 plus j. So 1 plus j, again we take common, it will become s minus 1, 1 plus j. So s minus 1, 1 plus j comes at the numerator. Okay, we have to go further. Let's plug in the polar value of this term. Okay, so we were here, we need to plug in the value of 1 plus j from polar form. So if you use your calculator, it will give you a value 1.414 angle 45. So we take this out, or we multiply actually. So it will now become s minus a 1.414 multiplied by 1.414 will give you 2. The two angles added, so it will become 180 degree. And now again we take help of the unit circle. 180 degree from this place brings it to minus 1. So whether it is positive 180 degree or negative 180 degree, the value changes to minus. So 2, 180, we can replace it by minus 2. So we replaced it by minus 2, s minus 1 remains there. Open it. So minus 2 plus 2. Okay, now we are coming close. We had s minus 1 here, we need to bring or make it s plus 1. So let's see how can we make it s plus 1. Because we can either use this formula, the denominator is s plus a, or you can use this formula or both of them. So here we are subtracting minus 4 and adding 4. When we subtract it, this will become minus 2, and we take common minus 2, then it will be s plus 1. Let's see. So this term is becoming minus 2. From here minus 2, minus 2s minus 2 and plus 4. And now we are taking common minus 2 from here, so s plus 1 plus 4. So this looks good. Okay, so we are here and now we separate the terms. So we separate these two terms. Minus 2 s plus 1 divided by the denominator, and 4 is written as plus 2 divided by the denominator. And now you see this matches exactly, this one matches with this. So from here you can write et cos beta t, beta is 2, so cos 2t. And similarly from here we can write et sin 2t. So let's see. So now we go to the time domain, trying to find ft is Laplace inverse of fs, and so Laplace inverse of this one, and this one. And with the help of table now, we can write the values. Minus 2 e minus t ut, the first one. 1 over SA is e minus AT, and we write UT with all the terms that we get because we are doing the unilateral Laplace transform. So we write UT. Similarly, the second term, 2 is here, and then e minus t cos 2t from here. And the third term, 2 e minus t sin 2t ut. Okay, now this is fine, your answer is complete at this point, but we'll go further steps to match the answer with those that given in the book. So for that we'll use this formula. A cos omega t plus b sin omega t can be written as c cos omega t minus theta, where c is a square plus b square and theta is tangent inverse b over a. Okay, now just manipulate. We take this minus sign inside, so it will be 280 common from the both, minus 1 cos 2t, and plus 1 sine 2t. We have taken this out. And now if you see, this is matching this form. This is A cos omega t plus this is B sine omega t. And now we can find these two values first, so we'll do that separately here. So minus A, this is A and this is B. So C is under root A square B square, so this is 1.414. And theta is B over A. So if you use your calculator, you will get an answer of minus 45. But we have to be careful because this is not the answer in this case. And to see this, let's go into the Cartesian coordinate diagram. So this is the y-axis, this is x-axis. We have minus x or minus A, so it will be somewhere here, and plus y, so plus y is here. So our point of intersection is this point. So our angle should be from here to here, not from here to here. So either we can add 180 with this, or we can just from here we can write directly that the angle is not minus 45, rather it is 135. So the angle theta is 135, and therefore our value of the function, this function, is actually equal to 1.414 cos 2t minus theta, so minus 135. Now we carry it here. Okay, so this is the value we have carried from here. And if you want, you can just multiply this, so it will be 2.828 ET. Remaining terms remain same. And in the book, instead of this, he has written in the form of under root, so we'll write that. So this remains same. This can be written as 2 under root 2 ET, this, and UT is taken out. So this is the final answer, and the answer given in the book is just matches what we have found. So I hope this gives you an understanding of how to solve this type of a problem. It takes time, but it builds your understanding. Thank you.